Welcome back, everybody. Today we're going to be seeing the differences between what we call types of current. There are two types of current when we talk about electricity. It's the alternating current and direct current. But one thing that needs to be clarified is that when we talk about different types of current, we're not talking about like physical differences. What we are talking about is differences in behavior, okay? The behavior of the current over time, It's still electrons flowing in a conductor. It's always going to be this, okay? This is always going to be what we're going to study. Either a wire connecting like a lamp, the wires in a car, feeding all power to the electric circuit of the car, a Arduino trace out of the board, which are doing the traces. It's always this. It's always electrons flowing in a conductor. We are analyzing is the behavior. What we are analyzing is the behavior of this current over time. Okay, that's the difference. The main differences is that this current can vary in voltage, so the voltage value may not be constant, and it may change in polarity. Change the polarity means that the positive and negative switch from time to time. The one that is positive becomes negative and vice versa. You may think, that's some strange behavior. Yeah, but stick with me for a second. Have you ever stopped to think, which of the wires I'm going to connect to my wall outlet is the positive and the negative? You don't. You simply connect it. And we're going to understand why in a moment. So, the easiest, most simple form of current is a direct current. It's direct current, what we call DC. It's when the voltage is ideally, in real life it's not like that, but it's ideally constant over time. And the polarity of the power supply, of both the power supply and the points we are comparing. If you remember the first video, voltage is a difference in potential between 2 points. So as we will see in other videos, we always measure voltage from one point in comparison to another. Always. And when we say we're dealing with direct current, the polarity is always fixed. The positive is always in one point, the negative is always in the other point, be it a power source or a component, whether we're analyzing power source or a component. So let's change the color here for a bit and think of examples of these things. The little 1.5 volts we have in our remotes, the 9-volt battery we use sometimes in our projects, the 12-volt battery we use in cars, see, these are all examples of direct current, because one terminal here is always positive. One of these terminals, that's how we call the connection points, one terminal is always positive, the other is always negative, and this does not change over time. One side is positive, the other is negative. One side is positive, the other is negative, and this never changes. So in direct current we don't have this problem. well, it's not exactly a problem, but we don't have this condition or this characteristic. See, and if we make a little graph here over time, let's say we are analyzing a 12-volt battery. Okay, a line here, so this is 0 volts. This is volts in the vertical axis, the y-axis, and here is time. Let's say this is 12. We'll see basically a line, not much to it, because as we can see for the first definition, the voltage is constant over time, so it's basically a straight line. It never goes down, never goes up. Eventually it will go down because it will lose its energy, but it's steady. It's a steady line as much as possible. And let's make something clear. This right here, the point of 0 volts, where the horizontal black line starts, the upper part is positive voltage and the negative part is negative voltage. You may start to think, Eric, how is it possible to have negative voltage? Isn't voltage like a force? Yes, exactly. But we also have negative forces. We learn physics in high school. There are negative values. But when you say a force is negative, it's not that you don't say that the force behaves differently. You only say that if this side is positive, if we get a negative result, it just means that the force is going the other way. And it's the same thing here. Every time we see a negative voltage, we just put in our minds that the current has switched orientation. It was going to one way in one direction and started going to the opposite direction. Okay. In a direct current graph, there would be no negative. Most of the time I don't see negative values in the direct current signal. So in a 12-volt car battery, this is what we would see. Okay, this is what we would see. Now, alternating current, on the other hand, that's a little bit different. So voltage changes over time. And this time, let's start with the graph. Okay, let's start with the graph. The most common kind of graph we're gonna see representing alternating current, so this is 0 volts, is going to be what we call a sine wave. It's going to start at 0, it's going to go some value, some maximum value, then it's going to go down, so it's going to reach the same negative, and it's going to the same value, and it's going again, and that's it for all the eternity. Okay, so it's going to reach a maximum value here, Vmax, let's call it Vmax, and it's going to reach the same value here. But remember, this is the negative part, so that means we have negative voltage. No, it just means that the polarity, this characteristic right here, the polarity has changed. It has reversed. It changed. It's inverted. The positive terminal is now the negative is now the positive. No. And when it reaches 0, it starts all over again. Okay. The positive, the one that used to be positive becomes positive again, the negative becomes negative again, and so on and so forth to infinity. Okay. Now, the changes in voltage as we are seeing here, in this case, it's a fixed pattern. It's not always going to be the case. Okay. So we have in AC voltage changing, and the polarity may or may not change, but usually it changes over time as well. So in DC we see a steady voltage and a steady polarity. In alternating current we see a change in voltage and maybe a change in polarity. Okay, there's one other characteristic these things have, which is the cycle. If you look at this point right here, the point where it starts at 0, goes all the way up, then to 0, then all the way down, then back to 0. This stretch of time right here, this is what we call a cycle, because this pattern repeats itself to infinity. If we were to analyze this all the way, now for a long time, we would see this repeating over and over and over again. So we say this repeating pattern is the cycle. And I wrote it wrong here, sorry. So the cycle is the time it takes for a pattern to repeat. No, the time it takes for a pattern to repeat, it's called a period. Okay, and it's in seconds, it's a unit. So how many seconds or milliseconds or microseconds or whatever it takes for this pattern to repeat? Let's say it takes, sorry, let me redraw this real fast. Okay, sorry people, I'm new to this, I'm really new to this. Let's say 20 milliseconds. 20 milliseconds is 0.02 seconds. Okay, the formula for period is 1 over f, which is frequency. And so frequency, the concept we're going to see in a moment, is also 1 over the period. So if we have our period, we can find out the frequency, the number of cycles that happen within a second. So we know the period, the time of one cycle is 20 milliseconds. So it's a really simple calculation. All we need to do to learn the frequency is 1 over 0.02. Okay, you can put it in your calculator if you want. It's going to be 50. So this means that if a period takes 20 milliseconds to repeat itself, in 1 second it will have happened 50 times. We have a unit for this kind of thing, for the frequency. We call it Hertz, Hz. Sorry again. Let me just erase it real quick. Okay. So you see we have not only voltage and polarity in alternating current, we also have cycles and periods and frequencies. Okay? But still, all we are analyzing is the behavior of the current, of the flow of electrons, its behavior. Okay? It's still a flow of, physically nothing changes. Physically it's still the same thing. Okay? There is no different current. There's a different behavior for the current. Okay? And here we have the same definitions as before. The only one we haven't seen still is amplitude. Whenever you see the word amplitude, I'm talking about the height of the wave. So if we have this wave right here, and we have another wave, now a red wave. You can see their frequency is different because the distance of the starting point when they start again is different. But which one of them is taller? This is taller. The red line is taller. The red wave is taller. So we say it has a bigger amplitude, which is basically more voltage. You know, the amplitude is voltage. The voltage of the signal we are measuring. Okay, we have already seen period and frequency. So where do we see alternating current? Oh, we see it every day. In the outlets in our homes. You know, in the US, I believe it's about 100 to 120 volts AC. And if you look at some Walmart or wherever, you'll see that you have possibly one of these things written, because the distribution network in many countries either run at 60 or 50 hertz, the frequency of the wave. It's the amount of times that the polarity between the plugs change. That's why we don't need to worry about which one of those is the positive and the negative. We just put it on the socket. Okay? This is the simplest and best example of alternating current. Okay? For the moment. And is it possible to have both AC and DC in the same signal? Yes. Okay, a signal can be like, draw something. A signal can have a variation here. See? It has a small variation, but it has a floor. It never goes below a certain point, which in this case is this line right here. Okay? So let's say this is 6 volts. And the red one is 1 volt. We can say we have a signal with 6 volts DC, since this part is constant, and 1 volt AC in the same signal. But this may be getting ahead of ourselves. Don't worry about this for now. We're going to see this later in the future. Okay? And again, a little dumb, boring questionnaire here. Just see, in the current, the voltage is fixed and the polarity never changes in time. Take your time and try to answer it. In direct current, the voltage is fixed and never changes. In alternating current, it can change its polarity or voltage or both. Okay? That's all for today. See you next time.